LuxMed ethylene oxide, ETO, sterilizer, sterilize critical moisture or heat-sensitive items.
Welcome to LuxMed, a testament to the Make in India mission, a global force redefining health.
LuxMed ETO sterilizers, using ethylene oxide gas, are primarily used to sterilize heat-sensitive medical devices, instruments, and other materials that cannot be sterilized using traditional methods like steam or high-temperature autoclaves. They effectively kill microorganisms by alkylating their DNA, ensuring a high level of sterility. How ETO sterilization works. Low-temperature process. ETO sterilization operates at relatively low temperatures, 37 to 63 degrees Celsius, making it suitable for materials that could be damaged by heat. Gas penetration. The gas can penetrate through various materials and packaging, ensuring thorough sterilization. Controlled parameters. The process involves carefully controlling gas concentration, temperature, relative humidity, and exposure time. Effective for various materials. ETO is effective for sterilizing metals, plastics, rubbers, textiles, and electronics. Wide applications. ETO sterilizers are used in hospitals, clinics, pharmaceutical industries, research labs, and food processing facilities. Advantages of ETO sterilization. Low temperature, suitable for heat-sensitive materials. Penetration. Effective for sterilizing complex devices and packaging. Wide applicability. Can sterilize a variety of materials. Safe for many materials. Won't damage most materials. Applications of ETO sterilization. Medical devices. Sterilizing instruments, endoscopes, implants, and other medical devices. Pharmaceuticals. Sterilizing packaging materials, vials, and syringes. Research labs. Sterilizing equipment, materials, and samples. Food industry. Sterilizing food products and equipment. Cosmetics and personal care. Sterilizing products and packaging. ETO sterilizer design focuses on creating a controlled environment to effectively sterilize heat-sensitive medical devices using ethylene oxide, EO, gas. This involves specific chamber designs, control systems, and safety features to ensure proper sterilization, remove residual gas, and prevent contamination. Key design elements. Chamber design. ETO sterilizers utilize stainless steel chambers with features like single or double doors, depending on the customer's needs, and designs that support both positive and negative pressure. Control system. A sophisticated control system monitors and manages parameters like vacuum, humidity, exposure, aeration time, and temperature. Safety features. ETO sterilizers incorporate safety features such as leak tests, gas detection systems, and emergency evacuation systems to prevent gas leaks and ensure safe operation. Process stages. The sterilization process involves preconditioning, setting temperature and humidity, exposure to EO gas, evacuation of the gas, and aeration to remove residual EO. Modular design. Some sterilizers offer modular designs to accommodate different sterilization needs, including preconditioning and degassing cells, and can be customized based on client requirements. Automation. ETO sterilizers can be fully or semi-automated, with options for one-touch operation and cycle programming. Record keeping. Detailed reports and graphs of the sterilization cycle are stored in a pen drive for documentation and traceability. Specific components and features. Heating system. Utilizes jacket and door heating systems for uniform temperature distribution. Vacuum system. Features screw vacuum pumps and roots blowers for high vacuum requirements. Humidity system. Provides proper relative humidity, RH, for each model steam generator. Control panel. Displays the phases of the sterilization process and offers manual control options. Air inlet filter. Ensures clean air entry into the system. PLC, HMI. Provides programmable logic controller and human-machine interface for advanced control and monitoring. Instrument printer. Records the sterilization cycle parameters. Important considerations. Process validation. ETO sterilization processes are rigorously validated using biological and chemical indicators to ensure safety and compliance. Product compatibility. The ETO sterilization process and its parameters are carefully studied to ensure safety and effectiveness for different types of medical devices and packaging materials. Residual EO removal. Proper aeration and degassing cycles are crucial to remove residual EO gas after sterilization to minimize any potential risks. Standards. The ISO 11135 standard provides guidelines for developing, validating, and controlling ETO sterilization processes for medical devices. ETO sterilization process. Ethylene oxide, ETO, sterilization is a low-temperature, gaseous process used to sterilize heat-sensitive materials like medical devices and pharmaceuticals. It involves exposing items to ETO gas under controlled conditions to kill microorganisms. The process typically includes preconditioning, gas introduction, exposure, evacuation, and aeration. Here's a more detailed breakdown. 1. Preconditioning. This stage prepares the chamber for sterilization by removing air, performing a leak test, and conditioning the environment with steam or humidity. This can involve a series of partial vacuums followed by nitrogen injections to purge the air. 2. Gas introduction. Optional on-process requirement, on-demand design, ETO gas is introduced into the chamber. The gas is often mixed with other substances like CO2 or steam to reduce the concentration of ETO and improve safety. 3. Exposure. The items are exposed to the ETO gas for a specific duration, depending on factors like the material and the device. ETO works by alkylating cellular proteins and nucleic acids, effectively inactivating microorganisms. 4. Evacuation. After the exposure period, the ETO gas is evacuated from the chamber. This is crucial for safety as ETO is toxic and explosive. 5. Aeration. This final stage involves airing out the sterilized items to remove any residual ETO gas. Mechanical aeration is often used to speed up the process and ensure residual ETO levels are below safety limits. Key considerations. Temperature. ETO sterilization is a low-temperature process, making it suitable for materials that cannot withstand high temperatures. Safety. ETO is toxic and flammable, requiring careful handling and monitoring. Validation. Rigorous validation is required to ensure the process consistently achieves sterilization and meets regulatory requirements. Aeration time. The time required for aeration can vary depending on the size, density, and material of the items being sterilized. LuxMed looking for offshore manufacturing partner for inline country that produces goods for local demands and supply to reduce manufacturing costs or access specialized capabilities and technology access to scale global business operation. For details, please revert.